So we got two vectors here, A and B, having equal magnitude r, are inclined at an angle theta. So when we have two vectors, vector A and vector B, inclined at an angle theta, such that magnitude of A is equal to magnitude of B, equal magnitude, right, is equal to r. Okay, now there might be a confusion between, there might arise a confusion between this r and the magnitude of resultant r, right? And it is not mentioned very specifically in the question otherwise. So, okay, anyway, I think since I've written, I think now to change all of this would be a really huge task. So let's anyway just try to understand that. So magnitude of r is equal to root of a square plus b square plus 2ab cos theta. They have A and B have equal magnitude. So A can be replaced with A, B can be replaced with A, so B is replaced with A. So A square plus 2AA cos theta, which is A square plus A square is 2A square. A times A is A square, so it is 2A square cos theta. Now 2A square is common in these two terms, so I can take them out. So that 2A square into 1 plus cos theta. Root of 2A square is root 2 into root A square into 1 plus cos theta. Root of A square is A, so this becomes root 2A into 1 plus cos theta is 2 cos square theta by 2. So I can plug in this root 2 outside. So it is root 2 into root of cos square theta by 2. Now root 2 times root 2 is 2. Root of cos square theta by 2 is cos theta by 2. So this becomes 2A into cos theta by 2. And the resultant, which is actually the sum of these two vectors, vector A plus vector B, and magnitude of resultant therefore becomes magnitude of vector A plus vector B is equal to 2A into cos theta by 2. Now, it is given in the question that having an equal magnitude R, so A can therefore be replaced by R, which gives us the correct option as option C. Vector A, magnitude of vector A plus vector B is equal to 2R cos theta by 2. Now you might be wondering, why do we have these options? Vector A minus vector B is equal to root 2 times R sine theta by 2, and another one which says vector A minus vector B is equal to 2R cos theta by 2. To understand this, we may have to understand the trigonometric expansion of cos 2 theta, which is very basic. See, I do understand that most of us don't need this amount of detailing to the very basic stuffs here, especially when it comes to trigonometric analysis. Even the fact that we're preparing for JEE means these things should come very naturally to you. But the reason why I prefer explaining that is to make sure that I am able to address the in my best way all the possible kinds of learners. Okay, so now that we have derived the answer, I think you can skip to the next solution. But if you are really interested to find out the rest of this and to have a better in-depth explanation, let's move on to the rest of it. So first, let us understand what is vector A plus vector B. So vector A plus vector B is actually the resultant. So what is resultant? In the most simplest terms, resultant is the vector sum of two different vectors. So we have vector A and vector B, where vector R gives the resultant of vector A and vector B, which is vector A plus vector B. Okay, and when we add two vectors, the tail of one vector should overlap with the head of the other. Okay, so this is vector A plus vector B is equal to vector R. Now, what would be vector A minus vector B? So vector A minus vector B is essentially equal to vector A plus minus B. So vector A minus vector B is equal to vector A plus minus B. Now, what is minus b? Minus b is a new vector which is similar to b in its magnitude, with only one difference, that the direction is exactly opposite, reversed. So if this represents vector b, minus b. Same magnitude, but just reversed in direction. Okay? So, what is vector A plus minus vector B? So, we have vector A, this is minus vector B. So, when we add vector A minus vector B, as I said, you can add only the head to the tail. So, we keep the head and bring the tail. So, vector A minus vector B, and this resultant, the new resultant obtained here, this again is the resultant vector. Why? Because resultant is defined as the sum of two vectors. The only difference here being, instead of B, we have minus B. So resultant is vector A minus vector B here. Okay. So that's one point that I want you to understand here. The second would be the expansion. What is cos 2 theta? It is cos theta plus theta. Now, what is cos theta plus theta? It is cos A cos B minus sin A sin B. So it is cos theta minus sin theta sin theta. What is cos theta cos theta? Is cos square theta sin theta is sin square theta. So basically we have cos 2 theta is equal to cos square theta minus sin square theta. Right? Now, if cos 2 theta is equal to cos square theta minus sin square theta, if cos 2 theta is equal to cos square theta minus sin square theta, if we replace sin square theta by 1 minus cos square theta, this becomes cos square theta plus cos square theta, which is 2 cos square theta minus 1. And if we replace cos square theta by 1 minus sin square theta, we get 1 minus 2 sin square theta as cos 2 theta. So which means cos 2 theta can be replaced by two different terms. One is 2 cos square theta minus 1, and the other is 1 minus 2 sin square theta. Does that make sense? Yeah. Now, if this is cos 2 theta, what is cos 2 theta by 2? So cos 2 theta by 2, which is actually what? Which is actually cos theta, can be obtained by replacing every term in this identity by theta by 2. Right? And what do we get? Cos 2 theta by 2 is cos square theta by 2 minus sin square theta by 2. Cos square theta by 2 minus sin square theta by 2. Now, we can replace sin square theta by 2 as 1 minus cos square theta by 2, and which gives us 2 cos square theta minus 1. So, 2 cos square theta by 2 minus 1. And similarly, we can replace cos square theta by 2 as 1 minus sin square theta by 2, which gives us 1 minus 2 sin square theta by 2. So cos 2 theta by 2 or cos theta can be expressed in two different ways. One, 2 cos square theta by 2 minus 1, or 1 minus 2 sin square theta by 2. Okay? Now, what is resultant magnitude of what is resultant is equal to magnitude of vector A, what is magnitude of R is equal to magnitude of vector A plus minus B, which is magnitude of vector A minus B, which by formula is equal to root of A square plus B square minus 2AB cos theta. Since the given vectors are equal vectors, right? Since it is given that magnitude of vector A is equal to magnitude of vector B, let us say is equal to A, B can be replaced by A, B can be replaced by A. So this becomes A square plus A square minus 2AA cos theta. A square plus A square is 2A square, A into A is A square, so this becomes 2A square minus 2A square cos theta, which further is equal to magnitude of A minus B is equal to 2A square, taking out 2A square as common, times 1 minus cos theta. Now, root 2A square can be written as root 2 into root of A square. What is root of A square? It is A. Now, what is 1 minus cos theta? So let me just write on it for you here. So from this expression, what is cos theta is equal to? Cos theta is equal to 1 minus 2 sine square theta by 2. Therefore, what is 1 minus cos theta would be equal to 1 minus 1 minus of minus 2 sine square theta by 2. 1 minus 1 is 0, minus times minus is plus, so this becomes plus 2 sine square theta by 2. So what is 1 minus cos theta is equal to 2 sine square theta by 2. Therefore, the expression becomes root 2 times a into root of 2 sine square theta by 2, which can be split as root 2 into root sine square theta by 2. Root 2 into root 2 is 2. Sine square theta by 2 is sine theta by 2. And since the magnitude of a and b is given as r here, a can be replaced by r. That gives us 2r sine theta by 2, which is equal to magnitude of a minus b. So there are two options which has magnitude of a minus b, which gives us 2r cos theta by 2, which is not the case. And if you're looking for such a correct option, I mean, if the question was framed differently, then the answer would be magnitude of a minus magnitude of b is 2r sine theta by 2. And look at the beauty of the question here. Why? Because the very first option, right? The very first option gives you a similar one. In fact, almost same. The only difference being root 2 in the option and the correct one being 2. Right? So it is also it is important that we get the correct answer, but it is also equally important that we try to understand why are the other options wrong, or is there any other message that the options is trying to give, right? Something. So learning the previous year questions is important, but understanding the options is equally important. All right. Okay. So yes. So